Alright, so this is a video editorial for the LeetCode Weekly Contest 489. I'd say like Q3 and Q4 were decent this time, but other than that, the contest was your usual LeetCode weekly or bi-weekly difficulty. Uh, so I'll be explaining the problem solutions in the Q1 to in the ascending order of the problem number, and after this you can watch me solve the problems live in the live solve section. I was able to solve this like Q3, even though Q3 and Q4 I feel are decent problems, I was able to solve them like fairly quickly because I was already like I'm like fairly decent like with the topics used for Q3 and Q4. So I was able to solve them, and like as a trend I had an stupidly like easily avoidable mistake in Q3, but like if I had avoided a mistake I would have gotten like my best rank, but that's the topic for another day. So start I'll start explaining my solutions. So Q1 was like fairly like it was a 3-pointer, so as expected it was like you just had to do what they said. We had 100 light bulbs from 1 to 100 and all of them are off, for every element in this bulb's eye, for the bulb's ith switch we have to like toggle it. If it were off we had to make it on, and like vice versa, and at the end we just had to return all of the bulbs which are on. So like this is fairly straightforward. We can make a frequency array where freq x is the number of times the x bulb was switched, and we count the number of times a bulb is switched, and at the end if it is switched odd number of times, that means it's on since it was initially off. So we push back, append it to our answer. So this was Q1. Q2 was fairly straightforward as well. Basically, for every element, what we had to do was we had to return the first element which has a unique frequency. So, like here, the frequency of 20 and 10 is 1, right? But the frequency of 30 is 2 since it's appearing twice, and 2 is a unique frequency when compared to 1 and 1. Hence, like we scan left to right, and the first element with unique frequency we find, we return it. Here, if like let's say 30 was appearing 3 times, and 10 was if 10 was also appearing twice, so if we had 10 here, then the frequency of 20 would be 1, 10 would be 2, and 30 would be 2. But the frequency of 2 itself is 2, right? Since there are 2 elements which are appearing twice. So in that case the answer would be 20. Here again the answer is 20 because 20 is appearing twice. This is appearing once and this is appearing thrice, but we want to return the first number. Even though all of these frequencies are unique, we want to return the first number based on the left to right scan. So yeah, and if no elements have a unique frequency, return -1. So this was straightforward as well. What we have to do was basically first we get the frequency of all the numbers, and then we get the frequency of all the frequencies, right? So first we make a map where we have the frequencies. I'm sorry. And then we get the frequencies of all the frequency in this frec map. Now we again scan left to right, and if the frequency of all the frequencies for this element is 1, that means this is a unique frequency and this is the first time we are seeing it, so we'll return the answer. Else at the end, if no numbers are found, we'll just return -1. And of course, since we have n less than equal to 25, this will work. Since the numbers are less than equal to 25 as well, there is no need to use a map. This can be solved using a global frequency array to like optimize the runtime. But yeah. This was Q3. Q3 I felt was a decent problem. So we are given a substring, we are given a string s of length less than equal to 2500, and we have to find the length of the longest almost palindromic what is this substring. And the almost palindromic substring is a substring where we have this condition. We can remove one element to make it palindromic. So like I'll have to whip up paint for this. Like for this example, A, B, C, A. Obviously A, B is a palindromic, like it's a palindromic string, right? But A, B, C, A, according to the problem, is an almost palindromic string because we can remove C, and then we have A, B, A, which is palindromic, right? So we can do at most no, almost palindromic is strictly after one removal, yeah. So we can make this we can make this palindromic after one removal, right? So the answer, like assume there were some, this was a substring in some larger string, and if we found this as a substring, so this would be a valid almost palindromic substring, since we can remove one character and uh, we are left with a palindromic substring. Also another thing here was another idea is if a what do we say, if we have a palindromic substring, we can always make it an almost palindromic substring by removing one character. Like, so if we have a b b a, we can remove b and we are left with a palindromic substring. And if we had, let's say, an odd palindrome a b b b a, we can also make this we can convert a palindromic into a palindromic again by removing the middle element, so we are left with a b b a. So by this idea, I use this idea, all palindromic substrings are all by design almost palindromic. So my problem statement is kind of simplified. I just had to find either a palindromic or a almost palindromic substring, the longest one for this string, right? So like if you had solved the longest palindromic substring problem, it's again, like if you need to have some like prerequisite knowledge for solving this, and that prerequisite knowledge here is DP and how to deal with substrings for DP. So assume we have some string S, and we are at some I comma j. I comma j means we are considering the substring from I comma j. Now I comma j would be palindromic if I plus 1 comma j minus 1 is palindromic and Si equal to Sj, right? So like here, if I take an example, b a b a b a, let this be I minus 1 and this I plus 1 and this be j minus 1. Now let's say somehow we know this is palindromic. Now we want to check if this is from I plus 1 to j minus 1. Now we want to check if I to j is palindromic as well. So if we know the middle section is palindromic and Si equal to Sj, let the characters here be x, then obviously this Si to Sj is also palindromic, right? And similarly we can get the length. If this is palindromic, we know the length here, and then we can simply add 2. And of course all length 1 strings, if Si, since Si would be equal to Si there, we would have a since it's one character, it will always be palindromic, right? So this is the problem. How you would solve this using DP? Like if character is same, we transition to I plus 1 j minus 1 and we maximize the answer. So this is how you would solve it without removals, but we can do at most one removal as well, right? Also the non-removals subproblem would be solved within the constraints, right? Now the idea is we can do one removal, so simply we can just track if we have done one removal or not. So I use this, what was my variable name? 1 second. I use the can skip, yeah. I use the can underscore skip variable to determine if I have done one removal or not. So here if we assume some conditions, let's say we are treating the L to R subarray right now, substring right now, my bad. If SL equal to SR, that means okay, it is possible that this is contributing to some palindromic substring, right? So here what we do is we add 2 to the answer, since we have added 2 characters here, and then we'll transition to L plus 1 comma R minus 1, which is whatever the answer is from the inside region. If it's a palindrome or not, we'll just add 2 to the answer, right? This is if both the characters are same. Now assume the characters are different, but we can skip one character here. Let's say we can do can skip is greater than 0. Obviously if we have already done our skip, we can't do the skip, right? If the problem were, let's say, we could do some k removals. Yeah, we could do some k removals. Then this would be initialized by a higher value, but yeah. So if we can do a skip, now we have an option. Either we skip the L or we skip the R, like how it's done in LCS, right? Either we skip this character or we skip this character. So in that way, the transition would be, we'll do max of L plus 1 comma R, which is we are skipping L, or L comma R minus 1, which is we are skipping R. And we'll only add plus 1 here, since the other character got skipped, right? and here we are assuming that somehow down the line a palindrome would be made. Now obviously the base case is if r is greater, if oh my god, if L is greater than r, that means you have an empty string, right? So there the base case is 0, and if L is equal to r, in that case the base case would always be 1, since one character string is always a palindrome. Now in the mistake which I made during the contest was I initialized my variable to 0, but here it can give you an overcounted answer since I am assuming that the thing inside was a palindrome. If it's not a palindrome, then this should get reflected properly, right? So if I should ideally initialize this to minus infinity. If this were a palindrome, if my inside answer results a palindrome, then I get a proper answer. But if it's not, then like this minus infinity stays minus infinity as a flag, and then I know that this is not a palindrome. So this was my solution. During the contest, I implemented it recursively. I just did this as I described. But after, this is a fairly straightforward transition. Like it's a single transition, so you can easily convert this into an iterative solution, which will give you a better runtime. So in my contest, I'll open my contest solution. One sec. Yeah, this was like 1 second almost, which is very slow for C++. I initialize my DP matrix values to -1, and then basically I'm checking for every I and j if it's a palindromic substring or not. Now assume I'm at some L comma R, right? Again, this is the base case, the empty base case. If both are same, then you return 1. Ideally, actually, this should be above. Since this is a base case, this should be above the memoization case. This might give me a wrong answer later. Got it. We'll see. This should work as well, obviously. Yeah. So nevertheless, we'll see what happens there. Else we do the memoization check, initialize it to minus infinity. If the characters are same, then we do this transition, this one which I described. And if they are not same and we can skip, we have a skip remaining, then we consume our skip, and we either skip L or we skip R. We maximize using 1. And yeah, we return this. And of course, we have to maximize this for all I and j, right? And the iterative version, it's even easier to see. Initialized it to minus infinity and 1 depending on the value, and 0 of course. It's the same thing. It's like just the code is more concise. So yeah, this was Q3. Q4 I liked. Q4 was a nice problem. Basically what we are asked is, we are given an array nums I, and we are given nums, and we are given a value k. What we want to do is we want to find the subarray with the largest XOR, the maximum value of XOR, such that the difference between its minimum and maximum element in the subarray is less than equal to k, right? So assume we have this subarray. So for this subarray, max minus min should be less than equal to k. And similarly for all such valid subarrays, we want to maximize its, what do we call, XOR across all such maximum this valid subarrays. Here the constraints are this 4e4 to less than 2 power 15 and less than 2 power 15. Now first of all, obviously your n square brute force won't work here. What the n square brute force will do is like iterate on all subarrays while calculating a running max and min. If this condition is valid, we maximize our answer using the subarray XOR, and if once this condition becomes invalid, we break. Now this idea, the max minus min thing is monotonic, right? Because as we increase our subarray size, max will always go up and min will always come down, right? As our subarray size is increasing. So this means this value will let this value be y. Y will always increase. So y will increase at till some point, and once it becomes invalid, it will stop being valid. Like all subarrays after this are invalid as well. Hence y is monotonic. So like if we assume the problem were some like find the largest subarray sum with this condition. So what we would do is like, well, let's try solving that easier problem first. The problem were to find the largest subarray sum such that max minus min is less than equal to k. So what we would do is like we could do a 2-pointer approach where let's say somehow we have the subarray max and min. That's a separate problem as well, finding the subarray max and the sliding window max and sliding window min and whatnot. We'll ignore that the details for now and focus on this subproblem. Like let's say we are at some what's this I and j. If this condition is valid, then all of the conditions inside this are valid as well, right? Since this is, as I've explained, this part is monotonic. So what we can do is, we know the prefix sum which is ending at j, which is pfxj. We want to maximize our subarray sum. I'm solving out sum right now. So we would want to find the minimum subarray prefix I in this range, right? Because then when I would do, let's say I've chosen this, then it would become prefix j minus prefix I, which will give me this subarray, and so on. So yeah, this was for the idea for solving this. Now of course for max and min I can either use a monotonic DQ. During the contest I use just fastable because the implementation is faster. But easily, like in a previous video, like I guess it was weekly 488 itself, I explained the monotonic queue approach as well, so you can look into that for this problem only. So yeah, so the problem is this is solved for what do we say, the subarray sum, but instead we are given subarray XORs here. Now if you were to translate that approach 1:1, what would happen is you would find the prefix XORs and you will try finding the minimum XOR, right? But minimum XOR is not guaranteed to give us the, what do we say, the total the maximum subarray XOR. So here we have some other sub problem. For a given set of this prefix XORs, basically for a given set of XORs, here like for this window I to j, we will have this set of prefix XORs, right? Like if we have a window I to j, we have to care about this prefix XORs from I minus 1 to j minus 1, right? Since what we do is we want to find a prefix XOR here such that when it is XORed with this prefix j, it results, let it be at prefix, let the best XOR resultant XOR be at k here. So we want to find k such that pfxj XOR pfx k here is maximized, right? Since XOR is destructive, and this will give us the best subarray XOR here. Now for this subproblem, this is straight up, this is another subproblem as well. How to find an element which will give us a maximum XOR when XORed with the current element. So like this is a standard idea. To solve this, what we do is we use a bit try. Like if you want to like look into it in much further detail, you can look up a problem where it is a maximum subarray, I guess not subarray, pairs or LeetCode or whatever. Well, I guess. Maximum XOR of two numbers in an array. Yeah. This was the problem. Given an array, we have to find the maximum result of this any pair of elements for the XOR. So for this, the bit try idea, basically the XOR try or bit try, whatever you call, will give you that. Basically what we do is, I'll give a very brief idea. You also need to have a prerequisite knowledge of tries here. If you don't know what tries are, look that up, then you will understand this. For the try here, instead of characters, we care about bits. So like from the root, we have 0 here, 1 here, 0 here, 1 here, 0 here, 1 here, and so on. So assume we insert a number, and it's obviously, since we have 15 bits, the height of this tree would be 15 here. And since 2 power 15, since 2 child for every height, the number of nodes, which is within the constraints. Now assume we insert a number, let's say some 0. First of all, we insert stuff in binary here. So if we insert, let's say 0 and 0, right? If you insert 2, we'll go this path. First, the 2 is 0, 1, 0, right? So we'll insert the largest bit first, 0, and then 1, and then 0. Similarly, now insert 3, so it would be 0, 1, 1. So we go this path. Now assume we want to find a number out of these two inserted numbers, which will give us the maximum XOR, like with respect to some x. For maximizing XOR, for maximizing the XOR result, like assume we have our current set bit is 1, and we have two options to either go to 0 or go to 1. We would want to go to 0, right? Since if we go to 1, XOR 1 would become 0, which will result in unsetting that bit. And here obviously we are iterating from MSB to LSB, since the MSB, if some ith bit has more weights, has a higher weight than all of the bits to its like lesser bits combined, right? So if you have 1 1 1 1 1 1 1, this weight, the weight of this 2 power, let's say x is greater than 2 power like x minus 1 summation, right? So that idea gets used. This is again a fairly nuanced topic. You need to have some, like you had to have you either have solved this problem before or know about this idea from somewhere else. So yeah, here the crux is like for maximizing the XOR, you would try to go to the opposing bit. And obviously if the opposing bit doesn't exist, then you have to go to the same bit. So that's what I did here. This is the wrong problem. First of all, this sparse table for max and min, it's not required. You can use a monotonic DQ. And first of all, we make a prefix XOR array. Since, don't forget, we have to maximize the subarray XOR, right? So basically for some pfx j, which is the prefix XOR at j, we want to find a maximum that this k such that this value is maximized, right? Which is in turn the subarray XOR. So for this, we first make a prefix XOR array. This is my XOR try. While our condition is invalid, invalid means the max minus min is greater than k, and this obviously is valid. We remove the prefix, the element which was the pfxi, which was corresponding to the element which is about to be removed, and then we try getting the current max, and then we XOR it, and then of course we insert the current element as well. And at the beginning we have to insert 0 since it's corresponding to that, the empty XOR subarray, right? So yeah, again this explanation might seem a bit confusing, but there are a lot of different like topics involved in this problem. We have the sliding window max and min for solving this condition, the k condition, the XOR idea for subarrays where the XOR of I to j is pfx j XOR pfx I minus 1, right? Where pfx is the prefix XOR. And again the XOR try idea. So again a fairly nuanced problem, but like my objective is not to explain the solution. I want to give you the ideas which you can use to solve these problems, since that is more scalable, right? Since now you know about these ideas, you'll be able to, like if there was some other XOR or a similar problem, you'll be able to solve it using this. So yeah, that was my explanation. Now like after this section, I'll add a live solve section where you can see me how I approach these problems in a live contest setting. Alright, bye.
डीपी से कर सकता हूँ, डीपी में डीपी लेट आंसर एल्स में काउंटर स्क्रिप्ट्स। हाँ ठीक है। fuck, sorry. Minus towards oh yeah. $15. Okay. मुझे अपना मिन मैक्स पास टेबल चाहिए। किधर हुआ मेरी स्पाइस टेबल? मिन मैक्स पास टेबल plus 2 3 I guess. हाँ, पास टेबल करेंगे, ठीक है। तो कम से कम अरे TLE कैसे होगा?